In previous class, we have seen about the JK flip-flops and JK flip-flop. We have seen about your JK flip-flop and what you mean by race around condition, condition. And now in this class, we study about the excitation table and characteristics table of a JK flip-flop. Before studying that, we just recall the truth table of JK flip-flop. JK flip-flop truth table is when clock input is 0, the output will be the previous state only. When it is 1, when you are giving 0 0, then it will be no change. When it will be 1, it will be 0 1. See, J will be equal to your S and K will be equal to your R. And when K is higher and you are getting the Qn complement is equal to 1, then it will be in reset condition. When J is equal to 1, you are getting Qn plus 1 as 1, then it will be in a set condition. When both are equal to 1, then it will be in a toggle condition. So toggle condition means here Qn plus 1 is equal to Qn plus 1 is equal to Qn complement, and Qn plus 1 is equal to Qn complement, and Qn plus 1 complement is equal to Qn. So this is the condition for the toggling. Okay, now we just see the characteristics table of an JK flip-flop. So what do you mean by a characteristics table? So a characteristic table will contains your Qn, J, K and your Qn plus 1. So that it is a 3-bit. So we just take from 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, and let me remove that one. And 1 1 0 and 1 1 1. So here we can see that when Q1 is equal to what is when J is equal to K is equal to 0, what will be the Q1 plus 1? Q1 plus 1 will be equal to Q1, so it will be 0 only. It will be 0. When J is equal to 0 and K is equal to 1, so what will be the Q1 plus 1? See this one. This condition we need to know. Okay, so this condition you just see this condition and you just tell me what is this. Is that Q1? The Q1 value is this one. So when J is equal to 0 and K is equal to 0, and it will be equal to Q1. So what is the value of Q1 here? It will be 0. When J is equal to 0 and K is equal to 1, what will be the value of Q1? What will be the value of Q1 plus 1? Q1 plus 1 is 0. When J is equal to 1 and K is equal to 0, what will be it will be 1 here. Just repeat. See, it is 0, it is 1 here. Then J is equal to K is equal to 1, what will be the value? It will be Q1 complement. See, what is the value of Q1? It is 0. Q1 complement means it is 1 here. It is 1 there. Okay, just 1 there. Next, what is J is equal to K is equal to 0? Q1 plus 1 is equal to Q1. So what is the value here? It will be 1. It will be once again 1. So when J is equal to 0, K is equal to it is 0. That is 1 here. J is equal to K is equal to 1 complement. That is 0. So this is the excitation table we get from the JK flip flop. So next we see about the your so this is not excitation table, this is the characteristic table. This is the characteristic table. Characteristic table. This is the characteristic table. Next we see about the excitation table. Next we see about the excitation table. So for excitation table we need to have the value of q1 plus 1 and j and k. For that we write 0 0 0 1 1 0 1 1. For j is equal to q1 is equal to 0, 1 minute. For q1 is equal to 0 and q1 plus 1 is equal to 0. What is the value of j and k here? So q1 is equal to 0 and q1 plus 1 is equal to 0. So this one, you just see this condition. I will just show you in the other ink. So you just see this condition. When both q1 and q1 plus 1 are 0, so what is the condition? J is equal to 0, but what is the k? K will be varying from 0 to 1. So that's why we have to put k as x. When j is q1 is equal to 0 and q1 plus 1 is equal to 1, when q1 is equal to 0 and q1 plus 1 is equal to 1, so this condition, q1 is equal to 0 and q1 plus 1 is equal to 1. So what is 1 and 0? Is there any other condition like this? Same condition? Can you see? No, you cannot see like that. So for here it will be 0. So here you can 0 and 1, 0 and 1. So what is the value? 1 0, 1 0, 1 0, 1 0. Okay. For j is q1 is equal to 1 and q1 plus 1 is equal to 0. So q1 is equal to 1 and q1 plus 1 is equal to 0. So this condition, then this condition. So q1 is equal to 1 and q1 plus 1 is equal to 1, q1 plus 1 is equal to 0. For that condition, sorry. So q1 is equal to 1 is this condition, and q1 plus 1 is equal to 0. So the condition changes. So q1 plus 1 is equal to 0 means this one, q1 plus 1. For that one we need to say yes, q1 is equal to 1, q1 is equal to 1, say. So there you can see j is varying from 0 to 1 and k is constant. So that's why we take it as k, and what is the value of k? It is 1 here. Now we see for q1 is equal to, now we need to see for q1 is equal to 1 and q1 plus 1 is equal to 1. This two condition and this two condition. So sorry, this two condition. 1 q1 is equal to 1, q1 plus 1 is equal to 1, q1 is equal to 1, q1 plus 1 is equal to 1. So we can say that j is equal to x. We take j is equal to x and k is equal to, we can see here 1 1 1 here. I just take other ink, 1 1. So 1 here, 1 here. So whether it is 1 1, no, so I cannot take that condition. So q1 plus 1 should be equal to 1. So yeah, this condition I can take, this condition I can take, and this condition also I can take, this condition also I can take. For that you just see it is 0 and 1, so it is toggling. So it's x and here 0 0, so it is 0, x and 0. Okay, so this is the truth table, this is the excitation table which you get here, and this is the characteristics table. I hope you understood about the excitation table and characteristics table, and if you are not understood, just watch this video once again and you will be getting the idea. So I will just show you the excitation table. So this is the excitation table, truth table and all for the JK flip flop. So next we see the excitation equation of JK flip flop.